Hello, everybody. So today we're going to be learning how to name acids and bases, as well as write their chemical formulas. It's something that we had done back in quarter two. You guys learned how to name and write formulas for ionic and covalent compounds. So now we're going to learn how to do that for acids and bases. The rules are a little bit different, but some of it you may find similar to what you had learned before. So to get started, we're just going to do a quick do now to review what we've been talking about so far with acids, bases, and pH. So let's just take 3 minutes. You guys will work on that, and then we will come back together and talk about it. So time is up. Let's go over the answers to this together. So for the first one, we have that HCl is breaking down into H plus Cl. So you should have said that that is an acid. For the second one, we had NaOH breaking up into Na plus OH minus. That one is a base. Number 3 has H2SO4 breaking down into H plus SO4 2 minus. This is also an acid. And then MgOH2 breaking down to Mg plus OH minus is going to be a base. Remember, our acids are going to form H plus ions in water, while our bases are going to form OH minus ions. And then what pH do acids have? What pH do bases have? So acids are going to be 1 to 6 and bases 8 to 14. And remember, 7 is neutral, which is what water is. And then what happens to pH is I increase my H plus concentration. So you might be thinking, because we're adding more hydrogen ions and we're making, we're adding more, right? We're increasing the concentration, you might think that our pH is going to increase. However, remember, a definition of an acid is that it's going to form H plus ions. And so with our acids, they're actually getting stronger as our pH decreases. So if we increase the amount of H plus, then our pH is actually decreasing. So our objective for today is that by the end of class, we will be able to name acids and bases as well as write their formulas. So just a reminder about pH, our hydrogen ion concentration, it is decreasing as we move down the pH scale. So something with a pH of 14 is going to have a very, very low hydrogen ion concentration as compared to something with a pH of 1, which is a very high hydrogen ion concentration. So the first thing we're going to do is learn how to name simple/binary acids. Essentially, all that means is that you have hydrogen with one other element. So it's not a bunch of other elements involved, it's just two elements that are involved. So the first step, you're going to write hydro for your H. So if we were trying to do this for HF, our first step is writing down hydro. Then we need to write the root word of our second element. So the root word is like before you get the ending, you take that chunk of the word. So fluorine, we're getting rid of that ending "ine" and we're just taking the fluor part. And then we're adding "ic" to the end. So hydrofluoric, and then that's your first word, and then your second word is just acid. So HF is hydrofluoric acid. So again, hydro for the H, we write our root word, we add "ic" to the end, and then we're adding acid. So these are 4 other binary acids, and I put the rules here for you. I want you to take a minute and try to name these on your own before we go over it together. So let's go over it together. So HCl, first thing we want to write down is hydro, then our root, which is chlor, we're adding "ic", and then acid, so it's hydrochloric acid. For HBr, it's going to be hydrobromic acid. HI is going to be hydroiodic acid, so that's iodine. We took that root, we got rid of the ine part, and we just added "ic" and acid. And then our last one is going to be hydrosulfuric acid. So that system is relatively straightforward. However, we do have a lot of acids that don't fall into the binary acid category. And so for those, we have a different system that we use. So for naming polyatomic acids, we have a different system. And you might remember that word polyatomic. We did learn about polyatomic ions in quarter 2, and that was when you had to name something that had more than just 2 elements, right? So in general, polyatomic acids are going to have acids with oxygen. So for example, HNO3, we can't name this with our simple naming system. It has oxygen and nitrogen in it, so it's polyatomic. And so this is our polyatomic right here, our NO3, and we have a list of our polyatomic ions that you can use in order to name them. So we are going to start naming polyatomic acids with our steps. So the first thing that you do is you just write down the name of the polyatomic ion. So in this case, you don't have to worry about writing down that hydro. It's not part of our rules. So you're going to find your polyatomic ion, write it down, and then if the ending of your polyatomic ion is 8, you're going to change it to "ic", and if the ending is "ite", you're changing it to "us". and then you just write acid as your second word. So remember, no hydro, and then you're just changing the ending of your ion and adding acid at the end. So for H2CO3, my polyatomic ion is the CO3, so we're going to come find it in here. That is carbonate. And so we're going to write down carbonate, but then we need to change that ending to ic and add the word acid, so it becomes carbonic acid. Let's try it again for HNO2. So looking for NO2 over here, we see that it is nitrite, so we would write down nitrite, change that ite ending to us, so it's nitrous acid. So remember, there's no hydro, you're just changing the ending of the polyatomic ion and then adding on that word acid. So we do have a few exceptions to those rules. So for H3PO4, you would think that when you take the root, right, we have phosphate. When you take that root, it would be phosphic acid, but actually it's phosphoric acid. So even though phosphate doesn't include that OR, when we name it, we do want to call it phosphoric acid, not phosphic acid. For H2SO4, it's going to be sulfuric acid. So looking at the sulfate, you would think it would be, we'd take the sulf, change that ate to ic, and it'd be sulfic acid. But we actually do name the entire element, so sulfur, sulfuric acid. And then H2SO3 also has an exception. So same thing as the sulfuric acid, it's going to be sulfurous acid. So instead of calling it sulfus, it's sulfurous acid. So those are just a few exceptions you would need to memorize. And that's about it. Everything else should follow the polyatomic ion rules that I gave you. So now I want you to try naming these 3 acids, and then we will talk about it together. So let's go over those answers together. So HI, this is one of our simple acids. So this is going to be hydroiodic acid. The second one, it is a polyatomic ion. So it's going to be acetic acid. And then H3PO4 is one of our exceptions, so that is phosphoric acid. So now we are going to move on to learn how to write formulas for acids. It's very simple to the way that we learned how to write formulas before, very similar. So first thing you're going to do is write down your hydrogen symbol, which is H+. We know that plus means +1. And then you're writing down the symbol of the other element, /polyatomic ion, with the charge that it has. And then you are just crisscrossing them and balancing, which is what we had done before. So here I have an H +1, and then I, remember that is in group 17, so that is going to have a -1 charge. It's a halogen, so +1 and -1, we crisscross that, we just get Hi. Now for chromic acid, we have our H+, and when you look on the polyatomic ion chart for chromate, we see that it's CrO4 2-. So now I'm going to take that 2, give it to my H, and then give the 1 to my CrO4. So it becomes H2CrO4. So for polyatomic ions, you will have to look at that chart to figure out what your ion is and what its charge is. And then it's just a matter of switching those charges. So I would like you guys to now take 3 minutes. I want you to try to write the formulas for these 3 acids. So our time is up. Let's go over these formulas together. So hydrobromic acid, we'll have our H plus, and then our Br minus to form HBr. Then we have our nitric acid, so we want to look over here. Nitric is going to be our nitrate, which is NO3 minus, and then we have our H plus. So again, those charges are just going to cancel out, so it'll be HNO3. And then we have chloric acid, so we're looking for chlorate. Remember the ic corresponds to 8. So that's ClO3 minus NH plus, so again, the plus 1 and the minus 1 are just canceling out, and we get HClO3. Let's move on to naming bases now. So our bases are typically going to end with the hydroxide ion. For example, NaOH, that's how you know that it's a base. But ammonia, NH3, is actually a base. It's a commonly known exception. So just keep in mind, if you ever see ammonia, NH3, that is a base. So for naming bases, the name of the cation, the metal, goes first. And then if it is a transition metal, you do need to put the charge of it in Roman numerals. And then you're just adding the hydroxide OH ending. So for AlOH3, we have aluminum. So I'm just naming that. And then we have hydroxide from our OH. Remember, aluminum is not a transition metal, so I don't need to worry about Roman numerals. So it's just aluminum hydroxide. Now for FeOH2, iron, we name that first. That is one of our transition metals. So we are going to need to figure out what the charge is. And then we have OH, which is our hydroxide. So one kind of handy trick about these problems is our hydroxide is always going to have a -1 charge. So in order to balance out the other element, you're just going to take whatever is listed here. Whatever number here is going to be your Roman numeral. So because this is a -1 times 2, we get a -2 coming from here, meaning that a +2 must be coming from there. But you don't have to go through all of that. Basically, all you want to do is just take whatever number is on your OH and bring it down here in parentheses. If there is no number, then it would just be a 1. So just remember, these are our transition metals here. And you do need to use Roman numerals to show their charges. So a couple more examples. We have NaOH. So we take our sodium, we write that down, and then we're just writing down hydroxide. Pretty straightforward if it's not a transition metal. For CuOH2, we know Cu is copper. We know our OH is hydroxide, and then we're just taking this little number here, putting it in parentheses. To write formulas for bases, it's very similar to what we did for acids. So you're going to write the symbol for your metal cation, write the hydroxide ion, and then crisscross and balance the charges. So for example, barium hydroxide, we have Ba plus 2, OH minus 1. So we're going to flip those charges. So now I have Ba, and then I have OH2, right? I took my 2, gave it to my OH. Remember, anytime you are adding multiple polyatomic ions, you do need to have parentheses. Now for tin 4 hydroxide, I have Sn plus 4. Remember, the Roman numeral corresponds to the charge on your metal. So Sn plus 4, OH minus 1. So I'm flipping those. The Sn now we just have one of those. And we have 4 OH minuses, so we can balance out that plus 4 charge. So you guys are going to try writing the name for those two bases and then writing the formula for those two. So take about 4 minutes, and then we will go over it together. Okay, so let's go over it. So for the first one, KOH, we just want to name our metal and then our OH ion. So it's going to be potassium hydroxide. For CaOH2, it is the same. So we want to name this element first and then our hydroxide. So it's going to be calcium hydroxide. Now for writing the formula, we have lithium hydroxide. If you look at your periodic table, lithium is in group 1, so it has a +1 charge. Hydroxide has a -1 charge. So this is just going to be LiOH. And then iron 3 hydroxide. So we have our Fe and our OH, and because we have a +3 charge coming from iron, we're going to have FeOH3. So remember, because of the crisscross thing, you would have Fe3 plus, OH minus 1, so we end up needing 3 OHs to cancel out that charge. So that is the end of our lesson for today. Remember, if you have any questions, I have tutoring Tuesdays at 1, Wednesdays at 3, and Fridays at 1:45. So please do come get help if you're struggling with any of this. I know it can be difficult to learn this stuff online, so please do come to tutoring if you need it, and make sure you go on Schoology and check out the other tasks that you need to do for this lesson. Thank you. Have a great day, guys.